that brought you the internet is reinventing it from the ground up. Cisco is building the internet for the future that will unleash an entirely new wave of innovation that will impact every single business and every single human across the entire globe. Building the internet for the future is both a challenge and a huge opportunity. We wanted to go and really rethink how you build critical infrastructure and how can you build a clean sheet architecture, both at the silicon level as well as at the systems level, to be able to create an infrastructure that enables our customers to completely rethink how their networks are built. We spent over the past 5 years and $1 billion building this groundbreaking innovation. We're not just building faster and more powerful networks, we're actually introducing significant simplicity into the infrastructure so we can help our customers lower their costs and deliver new services and new revolutionary technologies to their end customers. And as we drive more innovation around how we build networks, we're enabling technology that will further enhance how people and content connect with each other. I think these new innovations will help accelerate 5G into the marketplace, which will enable a whole new set of applications, from banking to augmented reality to how we do things like remote surgery. The ability to put massive amounts of bandwidth into everyone's hands will revolutionize every single way we interact on a day-to-day basis. Everything you know about the internet is going to change.
When you start to look at what's happened in the silicon space, there are far few players that can get into this game. This is a tough place to spend money, because if you have to invest in something for 5 years, there's not that many companies that have the discipline and the attention to keep after that. So we think this is really cool that Cisco is actually becoming a merchant market silicon supplier today.
Right now, service providers are in a challenging situation, which is the premise of having to get massive amounts of additional bandwidth to support 5G and 8K video. But they have to do it at the time when they get no new revenue from their customers. We've got this unique opportunity ahead of us to drive a truly fundamental change and radically shift the industry. So when we started thinking about how to build Cisco Silicon One and try and do something that's never been done in the industry, we had to both innovate on the technology levels, but almost more importantly actually on the organizational levels. That's one of the big powers that we have at Cisco, is that we have the leading ASIC teams, the leading hardware teams, and the leading software teams, all working together to try and solve customers' problems. And we brought all of this expertise together to rethink every aspect of the software design, the hardware design, the silicon design, and bringing all of those together to come up with the Cisco 8000 and the Cisco Silicon One. Trying to build a single silicon architecture which can be the best router, or the best switch, or the best fabric, all at the same time without compromises, is what we've fundamentally tried to solve. So if I compare Cisco Silicon One, the first incarnation of the silicon is called the Q100 chip. The Q100 is more than 2 times the bandwidth and more than 3 times the performance of any other routing silicon in the industry. We're also much faster than the leading fabric chip, but if we compare ourselves to the leading switching silicon, we're actually even more power efficient than that. And it's really the first time in the industry where there is a single architecture which has this potential to unify the industry. Customers no longer have to worry about, do I need buffering, or do I need programmability, or do I need large scale? They can have all of that while still getting the efficiency of switching silicon. They can focus all of their development and all of their effort on delivering value to their customers. What we've done with Cisco Silicon One and the Cisco 8000, because we focus so much on efficiency, we're able to now actually take a 10 terabit router and deploy that in a 1RU footprint at under 500 watts. So a 20 times improvement in power efficiency in just a handful of years. The more you think about bandwidth and you think about the fact that if I can deliver the bandwidth in an efficient way, all of a sudden I can consume that bandwidth and drive fundamental value. And so the real question is what efficiency can you deliver that bandwidth, whether it's power efficiency or cost efficiency? That really is breaking through many of the rules that everybody has always assumed has been true in the silicon industry for decades. And once you start breaking those rules, every assumption that people make when they come to a conversation gets challenged.
We're excited to see this coming together where a routing and switching platform can have that kind of a size, power, density, and the reach that we need in the ZR and ZR Plus optics and 400 gig and beyond, hopefully.
If you look at the amount of bandwidth increase that's happening, our service provider customers and web scale provider customers have to transition their networks to higher speeds, to 100 gig and 400 gig optics. And then at that point, optics becomes the front and center in the economics of their networks. So in addition to silicon innovation, we also have to focus on innovations in optics to bring the cost of optics down so the customers can transition their networks to higher speeds. As we move to higher speeds in optics, the complexity of the optics increases. This is actually the main cost driver. The complexity is the cost driver of the higher speed optics. So some of the complexities come from having to multiplex a lot of lower speed lanes into one higher speed. Some complexity comes from using an advanced modulation format, and these require that we have signal processing in the optic. So when you combine all of these things together, now you're asking a lot from one small optic. Silicon photonics integrates a whole lot of components into one CMOS IC chip. When you integrate a whole lot of components into one chip, you improve the yield and you improve the cost structure, and you're able to pack a whole lot of devices into a very, very small footprint. So this is very critical in building transceivers at higher speeds. What is really exciting is the amount of optical functionalities that we can integrate into this tiny silicon photonics device, and then manufacture it at a wafer scale, and then build transceivers that are very high bandwidth, and then plugging them into the Cisco 8000 router. And that enables a very high bandwidth, robust and resilient core for our service provider and web scale customers.
The scale that we have, that's the challenge. On average, our customers per home are using more than 250 gigabytes per month. These are big, big, big numbers.
In the beginning, the internet was really about connectivity. What service providers were offering was a way for consumers and enterprises to connect to a network infrastructure. When we look forward, we're really looking at experiences. So things like latency, how close you are to services, and the general experience of that consumer are going to drive the future of our network infrastructures. 15 years ago, the entire storyline was around what would you do with 92 terabits. The problem was we were enabling that bandwidth with 72 chassis and 80 total racks of space, and you needed a small room just to be able to house that type of bandwidth. With what we're launching today, we're able to get up to 5 times that bandwidth in a single rack unit. For every dollar that our customers spend in CapEx to build a network, they generally spend about $5 in OpEx to run that network. So the CapEx equation our customers are dealing with is, how do I double the size of my network every year without having a linear increase to the CapEx that it requires to build that network? So we have to rethink the tools that we're using to build those networks and actually build much more simple networks and simple network architectures that can take advantage of some of these new tools we're delivering today.
As you know, we design, build, and operate one of the biggest public clouds on the face of the earth. We have a global WAN that on average runs 30 billion packets per second. We have 54 regions around the globe and growing, and every region can be tens to hundreds of megawatts of power.
When we first set the goals for what we wanted to build with the Cisco 8000, we had to choose the right ASIC technologies, the right power technologies, the right cooling technologies. But putting these all together and putting them in a package that gave us not just market-leading density today, but expansion towards the future, 400 gig today, 800 gig tomorrow, and 1.6 terabit in the future, but really with an understanding of what technologies were going to change in that time is what enabled us to build the efficiencies that we've built into the Cisco 8000. What we're delivering today is a complete portfolio of systems based on some innovative technologies. The Cisco 8200 family enables us to put 10.8 terabits into a single rack unit. This is a higher density than we've ever had in the routing space and enables us to build systems that drive down to 4 watts per 100 gig. This is a 5 times improvement over other competitive fixed boxes in this space. The Cisco 8800 is a large high-density modular system which enables us to build up to 260 terabits of capacity into a single system at about 3/4 of a rack. We can enable large modular systems that get us to about 11 watts per 100 gig, so that allows us to actually build 14.4 terabits per slot and put up to 648 400 gig ports into a single device. We always talk about power efficiency as a metric, and we look at watt per gig or watt per 100 gig, but we're building extremely large, highly dense systems. So it may not sound like a lot when you're looking at a single interface, but when you start to look at hundreds or thousands of interfaces across a device, the power actually means a lot. So by building the highest power efficiency devices in the market today, people can build networks that you just can't build with existing infrastructure components. Many of the large web providers are going to drive dense 400 gig networks as fast as they possibly can. With the smaller devices, we can fit 10 terabits into a single rack unit, and we can push that capacity in places in the network that we never could before. So as we look at latency becoming a real concern for our customers and services pushing out to the edge of the network, the ability to drive massive amounts of bandwidth in POPs and in locations we could never put that much bandwidth before is enabling us to build very, very different network architectures.
It's a different space now when you disaggregate, and it's a different development model. And you're doing that with us. We have several projects that we're doing right now with iOS XR on white box that fit that model.
Simplifying and modernizing the network stack has enabled us to build a much more efficient iOS XR7. By streamlining XR7, we've been able to deploy on a 50% smaller memory footprint, which enables us to push iOS XR7 much further out in the network to smaller devices. That simplification of the network stack also enables us to decrease the boot times of the devices by up to 50%. As we put more devices in the network and as more information passes across the network, we have to focus on modernizing how we operate the network itself. So leveraging technologies like machine-driven interfaces and APIs, full automation support from day one, and streaming telemetry to get information from the routing devices, we can actually see more about what's happening in the network than we ever could before and make much more intelligent decisions about how we want to optimize network resources. Traditionally, most of the data that we operate on in the network is stale, and by the time we actually get the information, understand what's happening in the network, the anomaly or the event that we're looking for is already passed. We can actually focus on real-time access to data, and just like any application you use today, the more data that we can get from the devices, and the faster we can actually look at that data and do intelligent things on top of it, the more useful it's going to be for the network. By building cloud-tethered interfaces and enabling cloud infrastructure to optimize what we're doing on the network devices and the network itself, we can build much more efficient networks. One of the areas we've spent a lot of time with iOS XR7 is leveraging the cloud to do enhanced test and automation capabilities. So our customers can actually leverage test and automation tools that we've built, leverage them through the cloud, and certify and deploy our equipment much faster, leveraging tools and technologies that we use internally for test. When we talk about trust in infrastructure components like routers, really we're looking for how do we deliver systems that our customers can put in the network and trust their entire network infrastructure. So we have to start that from the ground up. The systems we're building are designed with hardware-based root trust anchors to allow us to have a known starting point for trust and security. We can then layer things on top of it like a secure boot infrastructure and signing images as customers deploy software on these systems so that we know that it's genuine Cisco software and can't be tampered with. We're actively monitoring all the different processes that are running in the device, and through our cloud-based tethering, we can provide a trust posture to show you should we remediate devices or are there issues that that we need to look into further across the entire network infrastructure. And so what we're really focusing on is delivering the next generation of infrastructure for the next 10 years that our customers can count on. We're extremely excited to deliver these new technologies to market. I can't wait to see what you can do with these technologies once you get them in your hands.
I want to create stories that take people through new worlds like a roller coaster. Movies have been around for about 100 years, and the communal experience in a dark room shared with a bunch of strangers, that's not going away. But it's how that experience changes over time. We're always looking for how we can project better, how we can shoot it better, how we can make it sound better. And the faster technology gets, the better it is for a creative person. 260 terabits a second. This sounds like a very scary thing. I don't even know what it is. It sounds like a dinosaur. But I talked about my dreams if you could do games and you can make the experience much more realistic. The faster you're able to transmit heavier images, the better your experience will be. Filmmaking is a creative medium that uses a lot of people. You need to be connected, and connected really well. An average 2-hour movie is about 2,000, 2,500 shots. This one has 7,000 shots. Visual effects from Singapore, London, Canada, Germany, San Francisco, Los Angeles. As networks get faster and more robust, I'll be able to talk to all the artists, and it'll have the different countries up there, so they're all hearing me. I'll be able to do it all right there. I see all this on the horizon. Technology is in its infancy, but it's building and it's growing faster. And I see that happening with Cisco.